At this point in time, I'd like to turn it over to Bill Goehrig, who's going to be walking you through how to build a agent which can monitor for changes and then actually report on those changes back to us. So Bill, if you want to start sharing, over to you.
All right, yeah. Thanks, Jason. So hi, everybody. My name's Bill. I work on iModel.js, and in this session, I'm going to show you how to develop an iModel.js agent. And so an agent is basically what we call any app that continuously listens for iModel events from the iModel hub and then does something as a result. So those events are usually that a new change set was pushed or a new named version was created. And do something is really, whatever you want it to do. You can write to a database, you can build reports, whatever you want to do with your iModel data and the summary of what changed, it's kind of up to you. Right at the start of this session is going to be a little different from all of our other sessions. It's going to be very code heavy. I've got a lot to get through, so I'm going to move kind of fast, and I'm a little clumsy with the keyboard and these sorts of things. So I'm going to be using a lot of snippets and copying and pasting things, but I'll try to explain everything as I go along. So the first thing I wanted to talk about is the new iModel.js agent starter. This is a new template repository we just published to GitHub, and this is a great way to get started writing an agent. It kind of helps you skip the boilerplate and jump right into what you want your agent to do. And you can access this from the resources there. It's in the Jumpstart homepage. But if we look at this README, the instructions are basically clone, npm install, set up the config, and go. So in the interest of time, I have already skipped ahead a bit, and we've already done the clone and npm install steps here. And this is what it looks like when you clone it. There's a lot of config files here and stuff like that. Just to keep things a little simple, I'm going to hide most of them, and we'll just focus on the things that we find relevant. So after cloning and installing, you need to set up your config, and that means creating this .env file. Here's the template for that. And this is sort of what mine looks like. Obviously, the first thing you'll need is a project and iModel, and so I've already got those IDs in there. You'll also need to go to the registration page that we showed yesterday to register your agent app, and that'll get you a client ID and client secret. You can then come back and paste that into your .env file. Just want to note that I actually do have a client secret in there. I'm just using a cool VS Code extension to hide it because it is actually secret, right? And I shouldn't share mine, and you should not share yours with anybody. This is basically the password that we're going to use to access our iModel. And then the last thing we need to do is make sure that we grant this client access to our iModel by adding it as a team member. You can go to Manage and add that email address here. You need to give it a role that is going to have read access to the iModel. And if you run into trouble setting that up, don't worry. It can take about half an hour to actually create that email address and everything behind the scenes once you've registered your client. So keep trying, and if it doesn't work in, say, an hour or so, then get in touch with us. There's probably something wrong. So I mentioned that this starter is kind of meant to help you jump ahead and skip a lot of the boilerplate, but I do want to spend a minute just going over what's in that boilerplate. This kind of comes with 3 files here, and I kind of want to step through that because I think it's important to understand what's going on and how all this stuff works. So the place to start would be main.ts. This is our entry point. This is what we're actually going to run when we do npm start or npm or node dot. You can see there's not a whole lot of logic here. We've kind of encapsulated all of the agent behavior and initialization and termination logic into my agent. That's just kind of, we consider that a best practice. You don't want a lot of that stuff in files that have side effects. That is, JavaScript modules that just the act of importing them does something. So we try to keep all of our side effects in main.ts and everything else in my agent to keep my agent nice and testable. So the stuff that is in main.ts, we use a package called minimus to get command line arguments. Here we set up the Bentley logger. The Bentley logger is Optional, for the simplicity, we're just going to be using console.log for logging in this example. But one thing you do want to do is at least do these 2 lines here to make sure that we print errors from iModel.js itself to standard out. And that's what we're doing here. You can also change this if you want to see more logging from iModel.js. Since iModel.js 2.0, iModel host startup and shutdown is async. So we're going to need to wrap all of this in an async function here because Node 12 does not support top level await. So we're going to wrap all this in an async function. And anytime we do that, it's good to wrap it in a try catch here because any unhandled exceptions here are going to turn into unhandled promise rejections, and they're not going to be treated properly as fatal errors unless we have a try catch there. And then just to be triple sure, we'll do the same thing down here below to make sure that we don't miss any unhandled promise rejections that come from anywhere else in the app. Then getting into this try block here, first thing we do is load agent config. That comes from the agent config file. Basically, all that's in there is we use the .env package to load the contents of this .env file and all those variables into process.env. Then we assert that they're all set. And now that we know that they're not undefined, we can return an object with those variables or with those values. And thanks to a little bit of TypeScript magic here, we have a strongly typed type definition for that object. So going back to main.ts, we've got our config. We construct our agent class. We'll come back to my agent in a second. We call initialize and await it. That's async. And then we have these 3 conditions here. This is where we check those command line arguments. And there's basically 3 ways you can run this. The first 2 are really for like local development or testing. You can pass -- latest to call the run method with the default argument, which is iModel version.latest. You can pass -- change set equals something to run with an explicit change set. Or this else block kind of handles the actual agent behavior, where we are going to create an event subscription in the hub, listen to that event subscription, basically continuously long poll the hub for these events, and then on each event, we're going to call the run method with that change set. So that's what we do here. We use this package I created on any key to wait for input before stopping that listener. One thing to note about on any key is it's not going to keep the app alive if we stop listening for some reason, right? It's not going to add anything or any strong references in the node event loop. So if there's some kind of fatal error that causes us to stop listening, we're not going to continue to wait for any key press. But then no matter what we did here, once that's done and we're either stopped listening for events or we finished running once, we'll call terminate, clean up nicely, and then I like to log at the start, and I think that helps kind of debug things, especially once you've deployed it. So now we'll get into the actual myAgent class, and what we've got here in the constructor is we're basically creating 2 clients. The first is an iModel hub client. That is what we're going to use to talk to the hub and listen for events and things like that. And then the other thing we have is an agent authorization client. That is necessary to actually authenticate with the hub and any other Bentley services. These scopes are kind of the defaults that if you leave the default scopes when you register your client, you'll have these 3 at least, and these 3 are the minimum you need to listen for events and read iModels. Our initialize method is really simple. We just call iModel host startup. The 2 config options we set is we always want to set the application type to web agent if we've got an agent. That's really important. And then this is not really necessary, but I think it's good practice. If we're creating our own iModel hub client here, we might as well tell iModel host and iModel.js itself to use that as our iModel client to download briefcases. There's no sense in having iModel host create its own for that. Now we'll skip to the run method here. The first thing you see here is create context. Basically, every call to any iModel.js services are going to need this client request context, authorized backend request context. So we do that so often, we've spun that out into a private helper method here. And all that does is sign in with the OIDC client and create and enter that context. So once we've got a context, the run method is basically your do something part of the equation. So in this case, we're going to download the iModel. One thing to call out here is download options. We're using sync mode fixed version, which just means just pull one version of the iModel. That's usually correct if you're doing read-only. And I think generally most agents, especially if you're reacting to change set events, should be read-only. Otherwise, if you're creating change sets and then listening for change sets, you're going to get yourself stuck in a loop there, right? Once we've downloaded the iModel, we can open that using briefcasedb.open. And then, this kind of hello world stub here is in the default starter. All we're doing is logging the root subject name. So the root subject is an element in the iModel that basically describes the contents of the whole iModel. And so we're just logging the name of that. And once we're done there, we close the iModel and we're through the run method. Listen is a bit more complicated. Again, we always need a context. And the whole listening and reacting to events part of this is really broken into two steps. So you have to create a subscription and then create a listener. So creating a subscription is basically sending a request to the iModel hub to say that you want a new queue created that you can listen to long poll events, and this subscription can be reused across multiple executions of your app. So in this starter, we're always creating a new event subscription and always deleting it and terminate. But if you wanted to be a bit more rugged and make sure you never missed an iModel event, you could create one subscription and keep reusing it. And the challenge for this session is all about just how to do that. One little caveat I will mention to that, though, is that the hub will delete any subscriptions that are not pulled at least once an hour. So if you are going to do something like that, you do need to make sure that you are running your agent at least once an hour. Otherwise, you're susceptible to losing that subscription. This is also where we choose what type of event we're going to be handling. There's basically two events you may be concerned about here. Change set post push event is basically any time there was a change set that was just pushed to the hub. The other event that's pretty useful is version event. That's anytime a new named version was created. I typically like to use change set post push event just because it lets us deal with each change set once, and we only have to look at one change set at a time, but your mileage may vary. You can also do both if you wanted. Just make sure whatever event types you have there match the event type you define in your listener function here. And if you've got multiple, you can use a union type like that. But again, for this case, we're going to focus on change set post push event. So here we define the function that's actually going to run each time there's an event. This is an async function, so we're going to wrap a try catch block in here again. We don't want unhandled promise rejections. And we're just going to log that error and say we failed if there is any error. But basically, all we're going to do in this callback is call our run method with an iModel version corresponding to the change set we just got. So now that we've got that function, we can pass that to create listener here. The other interesting thing about create listener is you do need to pass an auth callback. That's because this is basically going to start an infinite loop where we're continuously long polling that subscription we created. And even though we have an authorized context here, if we're in an infinite loop, that's going to outlive the expiry of the token we've got in that context. So we need a callback here to just tell the hub client how to be able to refresh that token. And that's basically all there is in my agent. The only thing I skipped is the terminate function, and all that does is kind of clean up after ourselves. It's nice to clean up after yourself, deleting the event listener and deleting the hub subscription. Deleting the event listener, by the way, should if there's nothing, if there are no other listeners or event timers or anything like that, that should eventually cause the app to kind of gracefully stop on its own. So that's all the boilerplate. Now let's talk about actually writing an agent here. So if I come back to designer view, I've actually created an iModel here using some IFC data, and I use the iTwin synchronizer to bridge that data and create this iModel. And we're actually going to use this iModel, and in this session, we're going to write 2 agents. So the first is kind of a warm-up. We'll kind of get most of the way through there, and we'll just console.log stuff, and then we'll start over with the second agent and actually expand on that and do something with it. So the first example I've got here is, let's say I'm involved with construction, and I am looking at these big concrete slabs, and I want to know basically anytime the material of these slabs change, because that may mean I need different personnel, different equipment, costs may be impacted, et cetera. So I'm going to look at some of these slabs here, and it looks like the material name is in this material name property here. And I don't really know what material name is or where it comes from, so I can go to the Schema Explorer here, and I can search for just material name. And that takes me right to this IFC material name property of this IFC bridge data mixin. So mixin is basically an abstract class that gives us some kind of quasi multiple inheritance, right? You can think of it as something that you can add all across your inheritance hierarchy to add some additional properties. And you can see these are all the places where we have these mixin properties included. So the cool thing about this first example is this is one of the few cases where we don't actually need to know the mixin name or the class name or anything like that. So I'm just going to save off this property name, and let's go back here. And so what we want this agent to do, let's say we just want to console.log the new material name anytime we see a change set with the material name changed on a slab. And also, while we're here, let's take a look at slabs. And you see we've got this IFC slab class, but let's try to be more generic and go with structural physical. That'll just be a little easier too. And so anytime we talk about new property names or changes to instances here, we're really talking about querying change summaries. And there's a great page in the EC-SQL tutorial that explains how to do that. If at any point you feel lost in the next couple steps, definitely check that out. It goes into some great detail about how change summaries work and how querying the change cache works. So now, with that all out of the way, let's get started actually writing this. So the first thing I'm going to do is create a new file called watchslabs.ts. And I'm going to export an async function here. We'll call that function watchslabs as well. And that's going to take our context and our briefcase DB. And before I forget, let's go to my agent and make sure we actually call watchslabs. I need to await it because it's a async function. I'll import it and pass our context and our iModel, which is here. That's our briefcase DB. Save that. And you know what? Before I do that, I've actually skipped an important step here. Let's actually run this. So I can do run build -- watch to start TypeScript in watch mode, and that's going to save me from having to constantly rebuild each time. Every time I save a change, it'll automatically rebuild. And then I can actually start the agent with just node dot. If you're in the directory, if you're elsewhere, you can do npm start. And you can see we created that subscription, started listening for events. If I press a key, we delete the subscription, and we're done. I can also do it for -- latest, and you'll see we downloaded the iModel and printed the root subject name. All right. So now if I go back and re-add this watchslabs, text model. We'll wait it. We'll come back to Watts Labs and start implementing it. So here's kind of the boilerplate for working with these change summaries. You basically need to extract the change summaries. What that's going to do is go through the change sets you've got, and the change sets are kind of an optimized binary format that are summaries, which tell us what changed and the actual information in the change set. And then we'll also be writing those into a separate database. This is separate from the iModel. And that database is called the change cache. And so what this call does is tells us to attach that connection to that into our current briefcase DB, so that we can now, when we query briefcase DB, we can query both database connections. We can query the briefcase itself and the change cache database. And then since we're doing change set post push events, each event is only going to be one change set, so we can just do current version only, and that means we're only looking at one change summary, and that's what this little sanity check is for. There should only be one. And we can query that change summary, and if we just console.log that change summary, we can see what that looks like. If I save this, and again, you can see we've got a change set here. Change summary includes stuff like the change set ID, the change set description, push date, et cetera. And so this brings me to one of my big tips for writing agents, which is you always want to focus on your run method, not your listen method, right? Because that's going to let you get into a tighter loop here where if I find a change set that I know is relevant and I can get my run method working with that, then I can keep running it and retrying it. And I don't have to constantly listen for changes, push a change with the synchronizer, wait for that event, and then see it happen. So I've already gone through and found the change set that's relevant for this agent. So I'm going to paste that in here, and we can see here's the change set and the change summary. And now let's actually get started querying. Like I said, we want to query the briefcase DB with that change cache connection added. So I'm going to go in here and I'm going to start writing an EC SQL string. So this is basically going to be a kind of straightforward query. We're going to do select c.opcode, and I'll explain this in a second, e.user label. EC SQL, by the way, is SQL. So if you know SQL, you already know EC SQL. It's just classes and properties instead of tables and columns. That's really all there is to it. And we're going to select, you see I'm using these two aliases here, so let's define them in our from and joins here. So we'll do from EC change.instance change. And so right away, we've got three things here. What's that? So this EC change prefix means we want to explicitly look at this change cache connection. That's not always required, but it's considered a best practice. And then change is our schema alias, instance change is our class. We'll give that the alias C, and then we'll join that with biz.element, and we'll join that on e.ec instance ID equals c.changed changed instance ID. One last thing, we want a where clause. So if we do where c.summary d equals question mark. And like I said, this is case insensitive, but I'm going to fix that so the spell checker doesn't yell at me. Now we need to actually run this query, so we can do that synchronously with prepared statement. And we need to bind our change summary ID into that parameter there. So we'll do change summary ID, and need to add an import there. And then one thing I like to do, instead of assigning this to a variable row, is I like to destructure this result. So we'll do opcode and user label And then we can just console.log that right here. And opcode, by the way, is going to be an enumeration. And so opcode is basically telling us how did an instance change. So let's recap what this query is doing. We're selecting all of the instances that changed in the current change set referred to by this summary. And then we're going to cross-reference all the changed instances with biz elements. So now we're only going to get changed elements, and we're going to get the opcode. How did it change? Was it an update, insert, or delete? And we're going to get the element user label for each thing that changed. I mentioned opcode is an enumeration. This is going to be a numeric value. One cool TypeScript trick you can do here is you can actually index into an enum name, and that will do a reverse lookup from value to enumerator name. And that's really handy for debugging or kind of local development where you don't want to sit and write a whole switch statement. So if we save this and run it with that relevant change set, what did I miss here? Oh, I forgot the alias. There we go. So there you can see we've got a bunch of updates, lots of elements changed, but we actually don't care about any element that changed, right? We only care about things with that IFC material name. And not only do we care about that material name, we want to see how it changed. So the first thing we'll do is we'll join the instance change there that we got there with property value change. And so each instance has one or more property value changes. We can join that like this. And we can filter the access string of the property value change. And the access string, in most cases, you can think of it as the name of the property. In a few cases, like struct properties or array properties, it's a bit different than that. But for things like primitive properties and navigation properties, the access string is the name. And so we'll put our IFC material name that we found in the schema browser right there. And now if I run this again, now we still get a bunch of elements that updated, but nowhere near as many as before, right? So now we want to actually get the values that changed, right? So the first thing I'm going to do is define a couple helper functions here. Oops. So the first one is query single row. That's just going to wrap with prepared statement, step, and get row when I know that I'm expecting only one row to be returned. And basically, we're going to return the row if there was one, or an empty object if there was no return value. Need to add some imports, like always. And then we've got this get property changes. This is going to take an instance change, and we'll come back to get one of those. And with that instance change, we're going to call build property value changes EC-SQL. And this is basically going to generate some EC-SQL to query the values of properties at a given changed value state for a particular instance change. So changed value state, change summary manager is very explicit. It's not just before and after. There's actually 4 changed value states. There's before delete, before update, and after insert. And you can query just that state. And then this last parameter is optional, but since we only care about IFC material name, we can pass the list of properties we care about, and that'll filter it down. If you don't pass this, it'll query all properties. So that's going to generate an EC-SQL query that we can then run with prepared statement, and I'm going to run it using my helper here. And since it's only returning one row, that's going to return an object. We're going to use object.entries to turn that into an iterable of name value pairs, and then we'll just log each one. So now how do we get property changes, right? So the first thing we want to do is instead of an opcode, we're going to get the EC instance ID of that instance change. And we'll just call that as change ID. And that means we no longer have an opcode here. We have a change ID. And so now we need to get that opcode back, and we also need to get an instance change to pass to get property changes. So we can do that via this Sorry about that, folks. My headset disconnected for a second. We can use query instance change to get that instance change object as long as we have a change ID. And that instance change object also happens to have an opcode, which is super handy. Now we can keep logging there, and we can also call get property changes, pass it our DB and our instance change. Now when we come back to the console and we run it again, see not only all the elements that had their IFC material name change, but the new updated value. So now we can actually kind of consider this almost done, right? The last thing I said was I only cared about slabs. So, we see some walls here and stuff like that. One great new feature in EC-SQL is this is keyword. And this basically lets us filter EC class IDs without having to do joins on meta-schema queries or meta-schema tables and things like that. We can just quickly see, is this EC class ID the class ID of structural physical slab or any of structural physical slab's descendant classes, right? Derived classes, sorry. If I wanted just to match SP slab, I could do only here, but remember we've got IFC slab, so we don't want to do that. And this can also take multiple classes if you want to do that as well. And this really makes filtering by classes or class names a lot easier. And so now if I run this again, you can see we filtered down to just the slabs, and that's great. So now let's actually test this out for real this time. We'll run it as an agent with just node dot. We're now listening for events, and I'll come over to the iTwin synchronizer, and I'll synchronize a change to this IFC file I already made. I'll hit synchronize, and this is going to take about 15, 20 seconds or so. And when that synchronizes, you'll see that we're receiving notifications for change sets. These are going to come in kind of asynchronously, and we're going to print the change summary as we have an opportunity to handle them. So they may be kind of out of order here. But we finished the synchronization, and so we come back here, and you can see that we got a data changes change set, and that contained a bunch of slabs that had their material name changed to vibranium. So that's great. We had an agent to catch that. That may impact construction quite a bit. We could go on from here and actually do more than just console.logging, but we're going to do that in the second example anyway. So let's actually just switch over to the second example now and talk about a new scenario, another example of what you could do with an agent. Let's take the case that I'm working in, say, purchasing, and I'm really concerned about long lead items. So I'm not really concerned about any particular property that's changing. I just know that I have, I know which items here are long lead items, which pieces of equipment or so on. And I just want to know anything about those changes. I want to know how they change, because that could impact my schedule, my costs, et cetera. This is kind of a contrived example, but I'm just going to sort of arbitrarily pick this large piece of HVAC equipment out front here, and we're going to say that this is a long lead item. But the first thing I want to do here is I don't actually care about this particular element, right? I care about this catalog item. So I could go and follow Roop's example and get the element ID, but that would only identify this piece of equipment, and I want to identify anything sort of that type. So again, this is a sort of contrived example, but I could find a property here that let me identify the kind of equipment that we're dealing with here. And so in that case, I'm going to use omni-class number to identify these rotary screw water chillers that we want to focus on. And so if we dig into that a bit, we know that that is going to be the description or the display label of the property that we're after. So we're going to have to go looking for that. And then the other thing I want to emphasize is that if I care about all of these properties and not just the properties of the element itself, I mean, you can see that, especially with IFC data, oftentimes you'll get a lot of these pset element aspects. So all of these are relevant to me. I don't want to miss them just because I'm only looking at this IFC energy conversion device instance. So we're going to have to also look at, by the end of this, we're going to have to look at all of these element aspects as well. So the first thing we want to dig into, though, is how do we identify this piece of equipment? So we've got our Omni class number property. We know that's on this pset Revit type identity data aspect, and we know that that aspect is being applied to an IFC energy conversion device. So if we take all that information and we go over to the schema explorer, we can, the first thing you might do is search for something like Omni class number. And all right, so we've got all those properties, and it looks like there's a lot of these pset Revit type identity datas. And in fact, if I go and I search for pset Revit type identity data, it kind of looks like there's one of these per IFC class. So that's interesting. We can already tell that we care about the IFC energy conversion device instance of that. So we could kind of infer what the name is of that. And sure enough, that's got an Omni class number property. So we're going to need to know the name of this aspect and the name of this property. I'll save both of those off. And we'll also need to save off the actual value that we care about. So with all of that, let's jump back to Visual Studio and actually start implementing this. So the first thing we're going to do is just kind of copy and paste our first sample and rename that to flag long lead items.ts. I can also rename the function to flag long lead items as well. And let's actually, kind of evolve this a bit and stop doing all the console.log statements in this. Instead, let's actually return a value. And if we're going to return a nice structured result, we should probably define that type. So the first thing I'm going to do here is add a Typescript interface for what this changed element report is going to look like. And to start, these three properties come from the change summary. So we'll include those. And then we'll have a sections property here that is just going to be an object that maps element labels to objects with a change type property. We'll start with just listing all the elements that changed and what the opcode was, or the string version of that opcode. And then we'll kind of evolve it from there, right? I'm going to skip over the EC-SQL for now because we'll update that last. Before we forget, let's actually remove this console.log and replace it with constructing a new report object with those three kind of shared properties and our an empty object for the sections. And we'll also need to return that down at the end of this here. One little optimization we might want to make is, if the sections is still an empty object, it has no properties, that means that there weren't any elements that changed, right? So let's return undefined there rather than an incomplete report, because we probably don't want to be notified if nothing relevant changed. And then we can come back to my agent, again, before we forget. We'll import flag long lead items and call that. And now we'll assign it to a report variable. And just while we're testing this out, let's still console.log that report variable so we can see what it looks like. Now we'll come back here. And the last thing I want to do is I've got another console.log here. So let's delete these two steps. We'll come back to get property changes in a second. And let's add these 3 lines here. So what we're going to do is, if report sections user label is undefined, or technically falsy, but in this case undefined, we will construct a new object and assign that to report section. Otherwise, we'll use the existing one. And then we're going to mutate that. And since it may have been a new object, we need to assign it back to our spot in the report sections. And then this is kind of the same as before. We're just assigning it to the change type prop there. And so basically, all the code is updated except our EC-SQL query. And there's not a whole lot that needs to change here, actually. We'll remove property value change for now and remove this stuff, which was very specific to our last example. We still want to be selecting change IDs in user labels from instance change and element. But let's, instead of joining property value change, for now, let's just look at joining that aspect that we cared about, right? So we've got that class name there. And we can join an aspect onto an element using the element navigation property on aspects. And the last thing we're going to want to do is filter this a bit more and say, use this aspect that we just joined and only look at aspects where the omni class number matches this. So now if we save this, and again, I've got a sort of prepared change set that I know is relevant and has relevant changes. So we're going to stop doing that. I'm sorry, I'm going to hard stop this. That's probably what caused the fault there. And we're going to, instead of that change set, let's use, oops, didn't copy it today. Sorry. This change set. That always happens to me. I'm not sure why. Now, when we run it with that change set I've got prepared, we get a nice object here with our 3 kind of common change set fields. We've got our sections. There's one element that changed, and that change type was an update. All right, so we're off to a good start. The last thing I want to do before I forget is, I think it's kind of nice, just a nice little flourish. Maybe we can order this by user label. That'll be nice to sort that alphabetically. Now we want to actually look at the property changes themselves and see how properties changed and what properties changed. So to do that, the first thing I'm going to do is add an interface here called property changes, and we'll add to our report object here and add a property changes. And that's going to be of that type we just defined. And this is going to basically, for each property, we're going to have an object that has our old value and our new value. Like I said, the change summary manager is very explicit and has those 4 different states, but we can kind of collapse into 2 states. And as long as we know the opcode as well, I think that'll be enough context to build a nice report here. So now we want to actually update our get property changes function. We're going to kind of start over here. And if we basically insert all of this, what we're doing here is we're creating a new property changes object. I've defined these 3 checks here because we're going to use them all over the place, and it makes it a bit more readable to have them in variables. And so basically, we need to run 2 queries, one to get the before values and one to get the after values. And we're going to run different queries depending on what kind of change this was. So the first case we've got here is the before values. We need before values if it was delete or an update, and we'll use that to determine what the explicit changed value state was. And then we'll, just like before, generate that EC-SQL and run it and iterate over the name value pairs. And so what we can do as we iterate over those is we can say index into prop changes with our name. And since this is the first time we've handled each property, we can assume it's always going to be a new object. And we're doing the before values here, so that'll be old value. and we'll just set that to value. And now we need to do the same thing for the new values. So instead of deletes and updates, we've got inserts and updates. And instead of before delete, we'll have after insert and after update. Same as before, except now, because these updates may have already had old values, we can't assume it's a new property anymore. So what we'll do is the same trick from above where we say prop changes name or new object. We'll just assign that directly to prop changes name. And then we can mutate new value directly here and set that to value. So we save that. Now we can come back down or up here and call get property changes with our DB and our instance change and assign the result to property changes. Cool. So now if I run this, and right away we hit this unfortunate limitation of const.log. It has sort of a max depth, and that's not really great if we've got these super nested objects here. So a great trick you can use here is you could JSON.stringify this, but I actually like to use the inspect function. That comes from the util module, which is a node built in. And you can pass any value there, and then a couple extra commands. So we can say false to show hidden, and we'll just pick 10 as a max depth. And this is much higher than the default max depth. And then if we pass true as that last parameter, we can keep our nice colors, which is great. And this colors are there, and the formatting is better than JSON stringify would have done too. It's just a really great trick for sort of printf debugging. So now we can see that the last mod property changed on this element, and the IFC description was also updated. We've only got a new value, not an old value, even though this is an update. So that probably means the old value was undefined. All right, so that's a pretty good start. Now we can kind of flexibly describe any changes to properties regardless of what the opcode was. But we're not done yet. Remember, we don't just care about this element that has this aspect changing. We also care about any element aspects applied to that element changing as well. So we need to elaborate a bit on our EC SQL query. But before we do that, let's change our types here one last time. And basically what we're going to do is add another layer here, because now that we're dealing with the element changing and aspects changing, let's group each set of property changes by the class that changed. And we'll still group everything under the user label, because these are all related to one element, right? It's either the element itself or an aspect applied to that element. And since I changed that type, I've got to come down here and update this as well. I'll just paste that in, and you can see we're still doing the same stuff here, but now we can kind of assume that this is always a new object, because we're only going to be handling each changed instance once, even though we can be handling, this kind of explains what I did here before. We may be handling each element multiple times. That's the reason for that. So now it's time to update our EC SQL. And the first thing we want to do is join with the two element aspect base classes. You can't just do element aspect, because element aspect does not define the element navigation property. Only the two derived classes do. So we need to do both. And we're going to do left joins here, because we don't know that this change was an element aspect or an element unique aspect, multi-aspect, or an element. And we don't want to limit to just something that was all three. That wouldn't make any sense. So we'll do left joins. And you might be asking, why not make this a left join? Well, we always want an element here, even if it's not the thing that changed. So what we'll do instead is we'll update the on clause here, and we'll say, instead of matching the element ID to the changed instance ID, we'll do instead is match it to either the changed instance ID or the element navprops from those two aspect classes. You could do a bunch of ors here, but I like in. It's just a little more concise. And then the last thing, this is kind of a sanity check here, but I think it's good practice. We'll use that is syntax again to filter changed instance down to just biz element or element aspect. The reason for that is that EC instance IDs aren't globally unique. They're unique for a particular class. So if we had, instance changes that matched all these things by, matching up to instance IDs, that could still technically be like a relationship or something that we're not looking at. We're just really looking for elements and element aspects. So now, if I save this and run it again, voila, we've got the screw chiller changed and the actual element changed. That's the IFC conversion device. That's what we were seeing before. But now we've also included these two aspects. And one of them is really important, right? We changed the number of fans and half number of fans. And we don't want to miss that. That's great and all. But the second one is not really important. And this happens a lot with bridges, especially, depending on the, how the data is aligned. We can get aspects like this where the only thing that changed was the checksum. Maybe the only thing that changed was last mod. And maybe let's, say that those are not as relevant to us. So we can filter things that only had those properties change by changing our EC SQL query. And we can come back in here, and now we'll join back with property value change again, and we can filter that access string. And now that we're joining with property value change, this is when we may have duplicate results because one instance change may have had many property value changes. So we'll add a distinct here. Now if I run that, I still get the last mod property in here because something else changed. That wasn't the only thing that changed. But this third instance is gone because the only properties that changed were either last mod or checksum. So as a general rule of thumb, you want to do as much filtering in EC SQL as you can. You could technically do a lot of this by just querying IDs out of here and then using all the APIs to filter in JavaScript. But if you can filter down to something even narrower in EC SQL, I highly recommend you do it. That's going to end up being faster and better. So now we're kind of done this, right? We've created a report that we can now do whatever we want with. We can write that to a database, post it to some web service. We can build a report. But since I care about being notified when something changes, let's take the example of sending an email. So I'm going to add this send email file here. In order to send an email from Node, you need an SMTP server. To kind of shortcut a lot of that, we're going to use a product called SendGrid. You can sign up here, and there's docs I'll share a link to in a second. They have a really nice Node API that you can use to send these, and it's great. But I also need to configure it. So I've got a SendGrid account. The other thing about this account is that you can sign up for a SendGrid account and send up to 100 emails a day for free, which is really cool. So I've already configured my API key, my sender and recipient emails. So I'm going to add them to my .env. I'm also going to add them to my agent config class so I can use a nice strongly typed object agent config. And now we'll come back to send email. This is all compiling. To save time, I already npm installed this package, but I would have also had to do that. And we'll come back to my agent, and instead of just console.log here, we can await, because that send email function was async. And we'll send email, we'll pass this .config, and we'll pass our report object. And so what we actually do in send email here is we configure who we're sending to and from. we hard-coded a subject line, and we're just going to use JSON stringify to get a text format here. We're going to pass these two extra parameters to JSON stringify to get a little bit of pretty printing, but it's not going to be very nice. And so now if I run this with my change set, I'm not sure what's going on with this. I forgot one very important thing. The report is possibly undefined, and that's intentional, right? We don't want to send an email if there's nothing really to report. So we're just going to check if report is truthy, and then only send an email in that case. What's going on with my console here? So let's come back to a new console, and we'll just do node dot dash dash change set equals. I will paste my known change set ID in there. Now, when I run this for that change set, I come back to my email account, and I've already got the notification. And that's great, but we can jazz this up even more if we want to make it a little easier to read. We could actually build up an HTML report from that report object. And to do that, I'm going to use React server-side rendering here. So I'm going to change this to TSX file. And again, I've already installed React and React DOM. So I'm just going to paste a bunch of React in here. This is pretty straightforward set of React components. The only thing that's a little messy here is we have to inline all the styles. Then I can just render static markup and put that in the HTML property there instead of using text. And now let's actually run this for real. So I'm going to do node dot. I'm going to come to the iTwin synchronizer, and I'm going to synchronize, again, some prepared changes. And I'm going to also create a name version while I'm at it. Now, this is a much bigger IFC file, and this probably can take up to a minute to synchronize. So while we're waiting for that, I just want to plug that if you go to the Jumpstart homepage and check out the resources for this session, you can actually get to the source code and data for this agent that I just wrote. All the source code for the finished product is up on GitHub. You can pull it. There's instructions for setting up the iModel. I've included the IFC files. Instructions for how to set the project extents and generate changes, and also links to how to set up SendGrid. So you should be able to reproduce everything I just did on your own and try it out yourself. The other thing I want to plug is the challenge for this session. We've got a challenge here that's all about how do I make sure I never miss an iModel Hub event. And so it starts from this finished agent, and you're kind of editing this agent and building on it and making something more rugged and kind of ready to deploy for real. Let's go back to the synchronizer. This is still waiting. It should be any second now. This finishes up. Like I said, it is a larger file, but I kind of want to show the whole workflow here. So again, to kind of recap, an agent is something that's continuously long polling for events. You kind of start it and run it forever. We're going to receive events, and we can see we just received 2 events from that synchronization I just did. And now if I go to my email inbox, go back to the inbox, and there I've got a new report that's nicely formatted, almost nicely formatted. And I can see not only did that screw chiller that I cared so much about have all these really important properties change on me, and I can see all these updated elements and element aspects, but I've also detected a whole new piece of equipment inserted and all of the aspects inserted and all of the properties. You know, the sooner I catch this and can notify, if I can do that with an agent, which is kind of like an iModel bot, I can be alerted right away and hopefully save time and money. So that's basically it for my session. I guess I'll turn it back over to Jason and we can get into any questions you had.
Thanks a lot, Bill. Great session. Really appreciate you walking us through that process and also highlighting the challenge opportunity that's there for others to take advantage. And likewise, highlighting that you have this example up there on GitHub for everybody to get a hold of. Do want to remind everybody that we'll be posting questions and answers that have come up during the last 2 days to the discussions section, as well as remind everybody to go and star the GitHub repository. Have time for 1 or 2 questions that came in as we were talking here, so let's go ahead and hit those real fast. The first was I'm going to paraphrase the question a bit, but it's relative to the difference between an iTwin, or a digital twin, I should say, pardon me, the difference between a digital twin and an iModel. And with the digital twin, is it a 3D model, a combination of different types of models? But really, I think the root of the question that we're seeing here is, can you help us understand the difference between an iModel versus a digital twin? Josh, maybe I could ask you to help elaborate on that a bit.
Sure. So the vision, Bentley's vision is that a digital twin is a much larger thing than an iModel, right? The vision is for iModel.js is openness. iModel.js can connect to essentially, I think I said it yesterday, any data source that's out on the internet. So an iModel is an important part of a digital twin, but a digital twin does not include an iModel, and iModel.js can, as an open standard, can provide value in all of those circumstances.
Great, thanks, Josh. And if anybody has particular use cases they'd like to explore and understand, is it right to put the information into an iModel? Is it better to do something with more of a mashup of data in a digital twin, where an iModel may be one of multiple data sources you're trying to tie in? Be happy to talk to you more about that in your particular use cases. So please do feel free to reach out to myself or one of the developers here at Bentley. And an adjacent question, maybe Roop, you could speak to this because I think you have some information, is relative to work we've done with Microsoft and if we support the IoT hub from Microsoft.
I think Roop might be having some trouble. I can
Josh,
take
maybe.
Jason. Yeah.
Thanks, Josh.
Yeah, so actually Roop and I did a project that illustrates the integration between iModel.js and Azure Digital Twins, which is a kind of a way of getting to the Azure IoT Hub. You can look for more information about this. I think it's in the resources already. There's a blog post called Road to IoT. If you look at our Medium blog, so that's iModel.js. I'm sorry, that's medium.com/iModel.js. You can find that IoT post. And there's also Microsoft did a deep dive. We did like an interview with them. So that's under, if you Google for Channel 9 Internet of Things show or IoT show. That one's not posted yet, but it will be, I think, in a couple weeks. So check that one out too.
All right, great. Thanks, Josh. Yeah, and I would encourage everybody to watch that video if you have a chance. It's pretty interesting to see how that all comes together and provides a good demonstration of the world of the possible. We have time for 1 or 2 more here. Is the data of the iModels divided into separate files? And if I would need to transfer an iModel project to another company in order to visualize it, what should I transfer? Kayla, are you able to take that one?
Yes, sorry, was not ready to unmute. Yeah, so all of the data within the iModel is within a single SQLite file, it makes up that iModel. But not all data will actually be in that iModel. Similar to what Josh was saying about the difference between an iModel and a digital twin, you'll have things like IoT data and reality data and others outside of that iModel. And so if you were to transfer or copy an iModel to a different project or location, you would have to consider moving those resources as well. But in terms of sharing the iModel to another company or a subcontractor or something like that, you can give read-only access to the iModel to certain people. so you can handle it that way instead of having to transfer it to a new project with different permissions. And if you have any questions about that workflow, feel free to stop by office hours later, and we can kind of go over what your specific workflow you're looking for and figure out how that fits in.
Great. I think we're about out of time here, so I'm going to start wrapping this up. I'll close out the Q&A. But again, if you have additional questions, feel free to reach out here on GitHub, attend the office hours. And likewise, I know for some of you, it's we have a globally dispersed audience here. I know those office hours are when you're probably hoping to be sleeping. If you are unable to attend, whether due to time zone differences or for some other reason, please do let us know. We're happy to work this up a individual time to catch up with you as well and walk through questions you have related to the challenges or other general questions. We are here to help and make your adoption and getting started as easy as possible. So I'm going to close out the same way I started, just by reminding you, as Bill and Roop both did, that we do have these challenges available. We encourage you to go in and take a look at them. They walk you through some hands-on exercises to take what you've seen and what's been shared the last 2 days and really start applying it and rolling up your sleeves, get your hands dirty. I want, on behalf of all of the development team here at Bentley with the iModel.js team, thanks for joining us today, everybody. We appreciate having you and look forward to working with you some more in the future. Have a great day.